All right, let's get right into it. There's one topic that's pretty much a guarantee you'll see in your next software engineering interview, and that's sorting. Seriously. If you want to walk in there feeling confident, you've got to have this down cold. So in this explainer, we're going to break down everything, and I mean everything you need to know to completely master sorting and, blow your interviewer away.
So here's the plan. First, we're going to tackle why sorting even matters so much. Then we'll jump straight to the easy stuff, the built-in functions that do the heavy lifting for you. From there, we'll level up and talk about taking control with custom comparators. We'll even get into some of the more pro-level details, like stable versus unstable sorting, and of course, performance, because big O always matters. And then we'll wrap it all up to give you that edge you need in your next interview. Sound good? Let's do this.
Okay, first things first. Let's start with the big why. You're definitely going to be asked about sorting, but why? What makes it such a cornerstone of basically every technical interview out there? And that's a totally fair question, right? Because sorting feels simple. But here's the secret. It's not just about putting things in order. It's a fundamental building block. When an interviewer sees you understand sorting, they see you get the big picture. Things like efficiency and how algorithms really work. Think about it. So many other hard problems, like searching or data processing, become almost trivial once your data is sorted. It's the key that unlocks 1,000 other solutions.
Okay, so let's get practical. And here's some good news. You almost never have to build a sorting algorithm from the ground up in a real-world scenario. In fact, most of the time, you absolutely shouldn't. Just look at the power of these built-in functions. It's basically a one-liner solution in most modern languages. Over on the left, you've got C++. You just use std sort, tell it the start and end of what you want to sort, and boom, done. Then on the right, in the world of Python, you've got a couple of great options. You can use the .sort method, which actually changes the list you're working on. We call that sorting in place. Or, and this is what I usually prefer, you can use the sorted function. It's a bit safer because it doesn't touch your original list. It just gives you back a brand new sorted copy. The big takeaway here, don't reinvent the wheel. For simple stuff, the built-in solution is your best friend. But don't let that simple one-liner trick you. The magic happening behind the scenes is, wow, it's incredibly powerful. These built-in functions are super optimized. A lot of them use a really clever hybrid algorithm, something like intrasort. What that means is it starts out with a super fast algorithm like quicksort, but it's smart. It has a safety net. If it ever looks like it's about to hit a worst-case scenario, it just switches to a different, safer algorithm on the fly. And what does that get you? It pretty much guarantees you get that amazing ON log n performance almost all the time. This is exactly why you always reach for the standard library first. It's got your back.
Okay, but let's be real, interviews are rarely that easy, right? They're going to throw a curveball at you. They'll ask you to sort things in a weird, non-standard way. Maybe you have a list of people and you have to sort them by their age instead of their name. That's where you've got to step in and take control.
And the way you do that is with something called a comparator. The best way to think about it is it's just a custom rule. It's a little piece of logic that you give to the main sorting algorithm. And all it does is answer one simple question over and over again for any two items. Does this one come before that one? And once you define that rule, you can sort by literally any criteria you can think of. It's super powerful.
Let's actually see this in action, because it makes way more sense with code. So here, we're trying to sort a list of, more complex things based on just one little part of them. In C++ on the left, the classic way is to write a whole separate little function that knows how to compare any two of your objects. It works great, but then you look over at Python on the right and it's just so elegant. You use this key argument and you can pass in a tiny one-off function, we call it a lambda, that basically just tells a sort, hey, for every object, just look at this specific piece of it. Both get the job done, but you can see how different languages handle it. The bottom line is you now have total control over the sorting logic.
All right, now we're going to level up. We're moving from what a good candidate knows to what a great candidate knows. Understanding this next idea, the idea of stability, is what can really separate you from the pack in an interview.
So what on earth is a stable sort? It's all about what happens when you have a tie. When two different items are considered equal according to your sorting rule. A stable algorithm makes you a promise. It says, hey, if these items are a tie, I promise I will keep them in the same relative order they were in originally. An unstable algorithm, it makes no such promise. All bets are off.
Okay, to make this super clear, let's look at an example. We've got this little list of data here. Each item is a pair.
a number and a letter. Our job is to sort this list just by the number. Now, the interesting part here are the two fives. We have 5A and 5C. According to our rule, they're a tie, right? And notice, in the original unsorted list, the A version comes before the C version. Remember that.
Okay, so now let's run this through a stable sort and see what spits out. The result is totally predictable. First, we get 1D, then 2B. No surprises there. But now, here's the crucial part. We get to our two fives. Because the sort is stable, it remembers that 5A came before 5C originally, so it has to keep them in that order. The promise is fulfilled. 5A comes right before 5C. And this side-by-side really just makes it crystal clear, doesn't it? On the left, you've got the stable sort output, exactly what we expected, but look over on the right. With an unstable sort, it might flip them. It's not guaranteed that it will, but the point is it could. The original order is lost. The final order of 5A and 5C is totally unpredictable. And by the way, knowing which sorts are stable by default, like Python's Tim sort, for example, is a massive pro-level detail to know for an interview.
All right, this brings us to what is maybe the most important part of any algorithm discussion, performance. And when we talk about performance and sorting, we are talking about big O. This chart tells a really dramatic story. On the left, you have an efficient O of n log n algorithm. And on the right, you have an inefficient O of n squared algorithm, like a basic bubble sort. Now, for just a few items, they look pretty similar, right? But watch what happens as n, the number of items you're sorting, gets bigger. The O of n squared algorithm doesn't just get a little slower, its runtime literally explodes. It falls right off a performance cliff. It's a disaster. And that brings us to this incredibly important point. In an interview setting, picking an O of n squared algorithm when a much better O of n log n solution exists isn't just a tiny mistake. It signals a major gap in understanding how algorithms scale. And honestly, it can absolutely be the difference between getting a pass and getting a fail.
Okay, so let's tie all of this together. How do you take all of these concepts and turn them into a killer strategy for your next interview?
Here it is, your sorting interview checklist. Number 1, always start with the built-in sort function. It's fast, it's optimized, it's reliable, it's your default. Number 2, be ready for that twist. You need to be prepared to write a custom comparator or a key function on the spot. Number 3, know the theory. You have to be able to explain what stability is and why it might matter in a given problem. And finally, number 4, know your big O. You need to be able to talk about the time complexity of what you're doing and defend your choices. Nail these 4 things and you're in great shape. Look, mastering these ideas gives you a toolkit that goes way beyond just sorting questions. It helps with a whole class of other problems. So now that you have this solid foundation, are you ready to put it to the test with a classic challenge? Think about this one for next time. Can you solve the Dutch national flag problem?